Okay, we'll start with part 3 of the quarter study guide review. We have the slope of a line, and for the slope of this line, we're going to take a look at where we cross, and we can count most exactly. So if you remember, these points are on the line, but they're also at an integer. So we're going to take a look at the change in y over the change in x, or rise over run. So counting this, we have 1, 2, and 1, 2, 3. But this is going to the left, so the slope of this line, most likely, is -2/3. Now you could tell a little bit more about this if the points were marked. So this is just an estimate. So let's take a look at question 17. What is the distance between the origin, and remember the origin is the point 0, 0, and the point 4, 7. So we're taking a look at the distance formula, and the distance formula, if you recall, is distance is equal to x2 minus x1 squared plus y2 minus y1 squared. So we have our two ordered pairs, and so we'll calculate the distance as being 4 minus 0 squared plus 7 minus 0 squared. So the distance is going to be 16. 4 minus 0 is 4. 4 squared is 16. 7 minus 0 is 7, and 7 squared is 49. So 16 plus 49 is going to give me 65. So the distance is the square root of 65. Now we would check to see if we can simplify this, because we do know how to simplify square roots. So I would divide this number by 5 and see that it's 13. And so since this is 13 times 5, this is not going to simplify. So the distance between these points, the origin and 4, 7, is the square root of 65. Number 18. Given a segment with these points, we want to find the slope. So if you'll recall, the slope is change in y, so it's y2 minus y1 over x2 minus x1. So we'll find the slope. So it's going to be 2 minus -4, which is going to turn out to be plus 4. So 2 plus 4 over 1 minus -2, so that's plus 2. So this is going to be 6 over 3, and this is not 1/2. A lot of people mix this up. The slope here is 2. Okay, so we went over the distance formula a little earlier. Okay, get that back in view, and we're going to use the distance formula to find the distance between these 2 points. So again, x2 minus x1. So 1 minus -2 turns into 1 plus 2 squared plus 2 minus -4, so that's 2 plus 4. So it's going to be the square root of 3 squared plus 6 squared. So 9 plus 36. The square root of 9 plus 36 gives me the square root of 45. And the directions did say be sure to simplify, so I am going to factor this into 9 times 5, or 3 times 3 times 5. So I have a pair of 3's under the radical, so the 3 is going to come out, and so that simplifies to be 3 square roots of 5. Okay, for the midpoint. The midpoint, if you recall, is an ordered pair, and it's x1 plus x2 over 2, and then y1 plus y2 over 2. Now, just a quick notice about the formulas. Slope was subtract, distance was subtract, and midpoint is add. Let's kind of keep those straight. So we're finding the midpoint from A to B. So negative 2 plus 1 over 2. And not forgetting this is an ordered pair. Negative 4 plus 2 over 2. So I have negative 1 half and negative 2 over 2, which gives me negative 1. So there is my ordered pair for 18. Okay. Number 19. A line segment has an endpoint at 4, negative 6. If the midpoint of the line segment is 1, negative 1, what are the coordinates of the point of the other end of the line segment? So if you take a look at the midpoint formula, I really have two things that I need to do. I have negative 4 plus some other x divided by 2 is going to give me the negative 1. So that's going to give me my x coordinate. And then negative 6 plus some y point divided by 2 is going to give me 1. And that's going to give me my y point. So I'm going to start by multiplying both sides by 2. Negative 4 plus x equals negative 2. So x is equal to, add 4 to both sides, 2. Multiply by 2, negative 6 plus y equals 2. So y equals, add 6 to both sides, 8. So it would make sense that the ordered pair that I'm looking for is 2, 8. The midpoint is negative 1, 1. And the other endpoint, the one that I started at, was negative 4 and negative 6. Not really a very challenging problem if you think about working backwards. Okay, number 20. Going into circles. The center is negative 3, 5. Because it has to be minus h, x minus negative 3. And the radius is going to be 7, or the square root of 49. Go on to the next page. So I'm going to write an equation for the circle with the center at 5, negative 2, and a diameter of 10. So it's going to be x minus 5 squared plus y plus 2 squared is equal to the diameter of 10. So if we have the diameter of 10, that means the radius is 5. So the equation would have 25 there. Okay. So here we have a segment with these endpoints, and this is the diameter. So basically what we're doing is finding the midpoint of these, and that will be the center of the circle. Just checking to see my airliner is going to give out before I'm done here, and it looks like it might. So we'll work for a little bit longer and see what we can come up with. So the midpoint, -4 plus 6 divided by 2, and 4 plus 2 divided by 2. So the midpoint is 4 over 2 and 6 over 2. So 2, 3. The length of the diameter, remember they're asking you to find the distance. So the distance between these 2 points is going to be -4 minus 6 squared plus 4 minus 2 squared. It's going to be -10 squared and 2 squared. Now careful here, -10 squared is 100. If you put that into the calculator without putting the parentheses, it's going to be negative. And that's because your calculator is doing what you tell it to. You have to tell it to do the right thing. Use the parentheses. So we have the square root of 104. So we do need to factor this. Can you factor 104? 2 into 52, 2 into 21, so a 3 and a 7. So we can take out a pair of 2's. And we'll have a 3 and a 7 left over. So this is 2 square roots of 21 for our distance. So the radius then would be half of that, or the square root of 21. So the equation of the circle would look like this. X minus 2 squared plus y minus 3 squared equals 21, because it's the square root of 21 squared. Okay, I think we're going to stop at 23. Let's get my airliner charged a bit. I'll see you later with the rest of it.